So we're going to get started. Hi, everyone. I'm Shelley from the Center for Mathematics and Teaching, and I'm here with my colleagues and friends, Cynthia and Mark. We began our work together at UCLA over 20 years ago, actually almost 25, with collaborations between the math department and the education department. There, we created and implemented PD programs for teachers, and that morphed into writing materials for students. We left UCLA about 2010 to form CMAT, and since then we have had several programs adopted by the state of California, and more than 40,000 students have used our programs nationwide in the last 15 years. I'm excited today to share with you 3 extended problems that we have created to introduce functions. These problems are part of a totally new revised edition of our MathLinks program, which is a new core program we designed to make engaging and meaningful math more accessible to more students. The new program that you're going to see activities from today is organized into 10 consumable student packets per grade level. 3 packets per grade level will be available for pilot in March. And the circled packets you see are available now. The entire program will be ready for the school year 2023. The activities we are doing today come from one of the 8th grade pilot packets that's available now. And if you like what you see, and I hope that you do, please stay on to learn more about piloting options and features of the program. Before we start, I want to give you some context. This is an outline for the 8th grade program. Today's problems come from the 4th packet that introduces functions. These problems all appear before we formalize slope and intercept, which is in packet 5. The work will also drive a need to know for equation solving, which is in packets 7 and 8 in 1 and 2 variables. Each of the 10 self-contained consumable packets in grade 8 includes 3 multi-day lessons, review activities, vocabulary activities, and student resources. We will begin today with an opening problem from packet 4 called Slides and Jumps, and then move to 2 problems that explore function concepts through multiple representations. So let's get started. Not working here. Why is it not working? Okay, here we go. Slides and Jumps is an opening problem that requires perseverance. Its intent is to engage students with concepts that will be developed in the lessons. I like to introduce the problem in about 1 class period and then give students time to work on it and then revisit it later so that they can explore patterns and generalize them. For Slides and Jumps, structured workspace is provided for students, and the teachers will have an answer key, lesson notes, and a slide deck to guide instruction. I'm going to show you later how you can get all of these resources so that you can try this problem. The challenge in Slides and Jumps is to move the markers so that they will switch positions. This is called level 1. That's a slide. That's a jump. And there is just one more step. I think you could probably figure that one out. There are a few rules to Slides and Jumps. You can only slide 1 space or jump over 1 counter. You can slide backwards, but the goal is to switch colored markers in as few moves as possible. So slide and slide is not going to be very efficient. With the rules in place, then we allow students to start level 2. Once the students understand the problem, I like to have them have at it, and they can complete and record more and more levels. In a recent field test that we did last summer, I learned that the word record does not mean the same thing to teenagers today as it meant to me as a kid, as many of them took out their phones to record the actions. I actually thought this was pretty genius. Let's watch Ramona complete step 2. 1, 2, 3, 4, 5, 6, 7, 8. Good job, Ramona. Of course, the goal is to keep track of the steps so that we can see structure and patterns. Students shared along the way and ultimately made a table. Here is level 1, which was a slide, jump, 2 slides and a jump for a total of 3 moves. Here we see Ramona's 8 moves and the completed table. Students even generalized. They recognized that the slides were multiples of 2 and the jumps were square numbers. The total move was a bit more challenging, but a few students recognized that they could add the algebraic expressions, and others confirmed that it actually worked. It was quite an aha algebraic moment in the classroom. A very fun time to be there. To wrap up this opening problem, I thought you might like to know what teacher Nathan thought about jumps and slides. He liked the lesson because it started out simple, but also challenged his advanced students. Nathan also appreciated that the problem pushed students to get an answer and figure out how to explain how they got it. So the next problem I'm going to share is a classic pool problem. Here the students will see the power of multiple representations, and they will contrast linear and nonlinear relationships, which are 2 very important ideas related to functions. Here is how the lesson might unfold for students using a slide deck that is available to you. We begin by establishing the context and check for understanding. Italic questions that you see here and in all of our slide decks are intended to prompt discussion. Then the students explore the problem using words, pictures, tables, and graphs. The answer key that you see here shows some of the work that students will do, and some follow-up questions guide students to write and interpret equations. Notice that these questions reinforce constant rate and proportional relationships. Two different visual patterns provide independent practice. Like many of our problems, this context affords opportunities to explore several related ideas at once. This helps to make this program more meaningful and efficient. And I think it's one of the hallmarks of the kinds of questions and problems that we do is that we try and make connections all the time. I have one more cool problem to show you, and then I'll share with you how you can get all of these resources for free. The final context is saving versus spending. Here, students will explore increasing and decreasing linear functions in a relatable context. If you want to try this problem, some of the resources available to you are a structured workspace, an answer key, and a slide deck with lesson notes. Again, let's look at the saving versus spending problem through some of the slide decks. First, we identify the variables. Then we ask students to interpret the meaning of the coefficient and the constants in 4 different equations. So one of the equations has an initial amount of $100 in the bank. One of them indicates $100 of debt. one shows savings, and one shows spending. Once students have that background, we move to the actual problem. This incomplete table shows the saving and spending data for Mateo, Dion, Talia, and Alia. Again, italic questions cue discussion, and numbered questions alert students to do work on their paper. A contextual meaning for slope and y-intercept are introduced through Dion's graph, where the y-intercept is defined and slope is explored. So we look at what the 10 represents on the y-axis as the y-intercept and the starting value. Take a look at what the constant rate of change is, and ask the students to identify slope and y-intercept in the other graphs. After the students write the equations, we dig deeper into Dion's equations. Here's Dion's equation. Again, we look at where is the y-intercept in the equation, where's the slope, and ask the students to identify those in the equations. In a previous table, students saw that Mateo's bank balance began at 0 and increased by $20 each month, while Talia's bank balance began at $140 and decreased by $20 each month. As you can see, Mateo thinks his equation is y equals 20x, while Talia thinks her equation is y equals minus 20x. This final slide in the deck sets up a critique reasoning discussion based on the statements of these two students. By the end of this part of the lesson, students will produce a table, 4 graphs, and 4 equations on the structured workspace that is provided. So to wrap up the first part of this webinar, I'd like to show you how you can access the materials that you've just seen. If you would like to try one of these problems, or a full lesson, or even pilot the entire Introduction to Functions packet, all you need to do is go to our website, click on Curriculum, and then click on Core Second Edition, and then Preview Core Second Edition. You might want to take a screenshot of this.
It is in the chat box right now. The
even
links are there.
Okay, for visual learners, you might want to take, all right, we move on. This will take you to the sign-in page. And after you sign in, you will have access to our preview materials for one packet for all 3 grade levels at this time. Today, we focused on grade 8, and when you click on that, you'll get the resources for packet 4, including the complete student packet, teacher edition with answer keys, slide decks, quizzes, and other cool support materials. Our materials are all copyrighted, and typically student packets are not printable. But for you, packet 4 is printable for now so that you can try one or more of these lessons and feel free to copy it for use in your classroom. I hope you've seen something that you like and that you would like to share with your students and colleagues, and that I've piqued your interest in our new MathLinks program. My team and I have worked on this program for about the last 5 years or more, and we began this work because we wanted to create a program that would reach more students with meaningful math. But since COVID, I think I speak for the team when I say that our goal has extended into the world of social and emotional learning as well. I want our program to bring some joy back to the mathematics classroom for both students and teachers. And at this time, I'd like to show you some of the features that we've designed that I think meet both these content and social goals. This is what we call our Big Ideas Wheel. The 8th grade program is built around 8 big ideas that combine domains from the Common Core state standards. The activities you saw today emphasized functions and also addressed some of the concepts associated with linear equations. Focusing on big ideas and connections made it possible for us to build a program that fully addressed all of the standards in just 30 multi-day lessons. Knowing that the meat and potatoes of the course can be completed in about 100 class hours, I think is huge, because it means that there really will be time in your school year for enrichment, for intervention, for projects, for assessments, for review, and for some of your favorite activities that you would like to do with your students. It adds variety for students, and it also means less stress for teachers who may be concerned about finishing all of the standards or struggling to decide what to choose and what to lose. The problems you saw today come from an opening activity and one of the multi-day lessons in a consumable student packet, that is packet 4. In addition, every student packet includes engaging group activities, such as a card sort that you see here. We've built activity routines into our program. Poster problems were so popular in some of our previous programs that we've included them in every packet in the new edition. Both students and teachers love this one, where students do problems and move around the room, share ideas, answer questions, and check each other's work. Spiral review in every packet provides continued and systematic practice of previous work. Here you see an algebra grid. Math educator Carol Greenis gave us permission to use some of her very cool puzzles as a recurring feature in our 8th grade program. Learning and using correct academic vocabulary is a big deal in our program. We include an empty word bank that appears at the beginning of every packet, and throughout the packet, students are prompted to write the definitions or pictures in their own words. At the end of every packet is a crossword puzzle for vocabulary practice, and precise definitions are provided in the back of every packet. Opportunities to reflect on learning are included too. Students can monitor their own progress on learning goals in the front of every packet. And a more in-depth reflection opportunity is provided at the end of every packet. As you see here, this includes that big idea wheel that we saw earlier, where students can discuss and decide how the big ideas were used and connected in the lessons that they just studied. Finally, every packet includes a student resource section with definitions and helpful examples. Since student packet lessons take just about 100 days, there's ample time for review in the packet, assessments, and customization. On the website, you will find variety, such as these features for struggling learners, and these features for all learners. We've also taken quite a bit of time and care to create thoughtful and useful formative and summative assessments. I'm especially excited about a simple rubric that we included so students can give each other formative feedback. This rubric is based on the math practices that are emphasized on national high-stakes assessments. We aim to empower students to give effective feedback so that they will be more invested in their own learning and improve their own responses. And this activity can also offload some work from the teacher as well. So it's a win-win for students and for teachers. Again, if you like what you've seen and your school is considering new core materials in next year or the year after, I hope that you will consider piloting one of the packets available now or in the near future. The circled packets are available now. The rest of them will be available in about a month, and the full program will be available by summer. When you pilot, you'll get one class set of materials for free. Those are the consumable packets, access to all the relevant teacher materials, and a walkthrough and ongoing support from MathLink's authors. Please contact us for more details. And finally, please mark your calendar because we will be offering more webinars in about a month. On February 28th, we're planning a webinar at 1:30 and 3:30 that will explore the world of geometry using materials available to pilot. And on March 1st, at those same times, we'll be looking at probability and statistics. Enrollment instructions will be in your emails in the near future, and they will be on our website soon. What happened there? Anyway, I hope that you all enjoyed the webinar, and we will stay on to answer more questions. And I thank you so much for your interest and the work that you do with students and with teachers. Bye-bye, everybody.